Welcome everybody. So this is a video on C programming mock test for the TCS NQT examination that is going to be held in the next month, or it is going to be held in at least 3 to 4 days, right? So August 3rd and 4th is the examination. So in this session we will see about some 3 to 4 coding questions which will be similar to the questions that can appear for the examination. So this video will help you to prepare not only for TCS examination, but it will help you prepare for competitive coding and other interviews and examinations also. So do watch this video. So let us get started. So we will increase the difficulty from one question to the next question, and let us solve 4 questions in this session. So the first question for this is, write a C program to print hello world without using a semicolon. So this seems a very challenging program, right? So you should write a C program, but you should have to print hello world. So you need a printf statement definitely, but you should not use a semicolon there. So how can you do that? How can you print hello world using printf without using semicolon? So there is a method to do that, and I am going to tell you how to actually do that. Okay, so let us go to our IDE, that is code blocks, and let us start programming our solution. So I should definitely include stdio.h since this is a C program. So then I'm going to have my int main, and I'm going to return 0 by default. That is definitely there. So now I should have a printf, and I can print hello world, right? But what I should do is I should not have a semicolon here. So how to do that? So one of the strategy that you can use to do that is you can say if in the bracket, you can say printf, you can say hello space, and before the printf you should say not printf. Okay, and then if this is true, you should just have a semicolon. Else what you should do is you should printf world. Okay, so you can do that also, but I'm going to tell you a simpler method than that. So my method is, you should say if printf hello world, right? Just open a bracket and close a bracket, and that's it. So now if you run, you should have your world here only. Okay, we are not going to use a separate printf. So now if you run this program, you will get a hello world prompt on your screen, and you have not used a single semicolon in this whole program, right? So this is going to be, so what happens here is the logic is that, so let us go here. So you know that you have a string, that is your string is, let us say, hello world. Okay, so you have your hello world string. So this is your string hello world, and what you're doing is you're enclosing this in a printf. Yes, we are going to do that. So we did that. So you have, my handwriting is very bad now. So you have a printf. So what you did was you enclosed, what we did was we enclosed this in an if condition, and we just said if this is true, just don't do nothing. Okay, so you can also insert a semicolon here, just a semicolon representing that you're not doing anything and the program is when this is executing. So what happens now is that here when you, what this function returns is that, if you have seen our previous videos, we have prepared you for these questions, or we have solved similar questions before. So this printf will return the length of this character. So what is the length of this character? HELLO. So 1, 2, 3, 4, 5, 6, 6 including this space. So 7, 8, 9, 10, 11. So it will return 11, which is a non-zero number. So this statement get converted to if 11. So if 11 means true, and that will execute the statements that are there in this if block, right? So here, remember, we are not using a semicolon. So this is going to be printed on the screen. This hello world is going to be printed on your screen. Okay, so, and then there is no statement to execute when the condition becomes true, and then you will just return 0. Okay, so we have used so earlier I said we have used not used a single semicolon. So we have a semicolon here. I will take this semicolon out, and I will take this semicolon out, so, and I will make this as void main. Okay, so now when I run this, I'm getting a hello world. So this program we have not used a single semicolon, not even for a return 0. So in the previous program we had used a semicolon for the return 0. So this is the way you can print hello world without using a semicolon. So we have solved this question. That is why let us mark that done. So this question is done. So now let us go for the second question of this video. So our second question will be, write a program to convert a number from decimal to binary. So we should write a program to convert a decimal number to a binary number. So let us try to understand what is happening here. Okay, so I'll fill this with black color. That will enable me to write in white color. Okay, so this looks better, I guess. So what we should do is, let us say I have a number. It is not writing. Okay, I have not selected the size. It is not writing in white color. I don't know why. Okay, let us undo this. Okay, yeah, my bad. So let us do is, so yeah, so now I have a number. Okay, so that number is say 300 or 30, or let us take a smaller number. Let us say I have 11. So now this is in decimal, as we know. Okay, so now what you have to do is you have to convert this to binary form. So what is 11 in binary form? We can take this as 1, 2, 4, 8, right? So these digits are enough. So 11 is 8, 9, 10 and 11, and this is 0. So 1011 in binary represents 11. So we have to write a program to convert any number, say for example 315, to decimal, from decimal to binary. So if you have to do this manually by yourself, then this is a very difficult task, because you should know all the indexes, and then you have to insert ones and zeros there, and then you have to write this number in binary form. So what should be your logic in order to convert this in integer number? So in your program you're going to just say int n. Okay, so you have to convert this to binary form. So how are you going to do that? So let us discuss the strategy to convert this program into binary. So the method that you can follow is, say, I have a number n. Okay, my bad, this doesn't look good. Okay, this is number n. Okay, what I'm going to do is I'm going to take this as input from the keyboard from the user. So this number contains the number that was entered by the user to convert into a binary number. So what I'm going to do next is I'm going to create also, let us say I'm going to take another variable called count, and I'm going to initialize it with 0. I'm going to create an array called b, that is binary, and this array will be 32 digits long. So any number within the range can be represented using a 32-bit digit. So next what I'm going to do is I'm going to take n and I am going to mod it with 2, right? So I'm going to mod it with 2 and I'm going to store that result in b of c. So b of 0 will now have n mod 2. So next what I'm going to do is divide the number by 2, okay, and store it in that number itself, and then I'm going to increase my count. What I'm going to do is I'm going to put this in a while loop, okay, saying number should be greater than 0. So I will explain you this logic. So let us take a sample number. Let us say I want to convert my number 8 or let us say 7, okay, to binary. So what happens is initially the number count will be, you will take 7 from keyboard, you will initialize c is 0 and you will create an array called b which is of size 32. Then what will do, when the number is greater than 0, your binary array will have the the index 0 of this array b will have 7 mod 2 is 1, right? So because 2 3s are 6 and 1 is remaining, so you are going to store 1 here. Then your number is equal to number by 2. So what this number becomes, 7 by 2 is 3.5. That 3.5 in integer you're going to store it as 3. So then again c is increased, so you'll go to index 1 again, n is 3 is greater than 0, this condition is checked, this is true, it comes here again, 3 mod 2 is again 1, so you're going to store your 1 here, and again n is equal to n by 2, so 3 by 2 is equal to 1.5, that is nothing but 1, right? So now what you're going to do is again n is equal to n by 2, so yeah, so n became 1, so c++ happened, so your count became 2, and after that 1 is greater than 0, and then now what happens is p of 2 is equal to 1 mod 2, so 1 mod 2 is 1. Now what happens is n is equal to n by 2, so 1 will become 1 by 2, 1 by 2 is nothing but 0.5, that is 0 in integer. So then c++ is increased, so c becomes 3, okay, these are actually empty, so c will come here. So n should be greater than 0, but now n has become 0, so this condition is going to exit, so it is going to exit this condition. Now while printing the number, while printing this binary digit in your program, you have to print it reverse, 1 1 1. So since all three are 1 here, it doesn't matter for us. So this represents 7, so this is 1, this is 2, this is 3. So 3 plus 2 plus 1 is nothing but 7, right? So this is the logic that we can use in order to convert a decimal number into a binary number. So let us code this in our IDE, and let us see how well do we write the program, and how can we execute this. So I'm going to, what did I do? Okay, so what I'm going to do is I'm going to just remove this, let void main be there. So what I'm going to do first is I'm going to declare int num, and what I'm going to do is I'm going to say scanf %d of ampersand num. So I am taking num as an input from the user, right? So now next what I'm going to do is I'm going to say int count is equal to 0, and I'm going to say binary of 32. So why 32 is because of 32 bits, okay? So binary of 32 array can store 32 integers, so each integer represents 1 bit in binary form, so that is 32 bits. So next what I'm going to do is I'm going to say while num is greater than 0, I'm going to say binary of count is equal to num mod 2, sorry, num mod 2. So next I'm going to reduce num as num equal to num by 2. So I'm going to increase my count here. So this is exactly as the logic that I told here. First we're going to store the remainder for 2, right? So how this is similar is that, so if you are going to manually convert a number, okay, so let us say I want to convert my number 7, okay, to binary. So what I'm going to do is that first I'm going to take 2 here. So what I'm going to do is I'm going to divide it by 1 or 0 either, okay. So let us say I'm going to divide by, say, 2 ones are 2, okay, and I'm going to okay, I'm going to say 2 threes are 6. I'm going to subtract the 1 and I'm going to take the remainder, and every time I take the remainder, that remainder is going to a binary number. So that is exactly what we have done here. So every time we divide it by 0, before dividing we are going to take that remainder as because this mod will give us a remainder, we are going to store it in an array. So now what we've got is actually this binary array will now have the number in reverse form. So what our job is to print that number from reverse. So what we'll do is we'll say, okay, so we'll say for int I is equal to count minus 1, we have to print it from reverse. So from count minus 1 to 0 we have to print. So I should be greater than or equal to 0. We have to say I minus minus, right? We have to say printf percentage %d. We have to say binary of I. So what happens now is that this binary array, which has the number in binary format, will be printed in reverse. That will give us the binary representation of the number that we entered here, that is num. Okay, so let us try to execute this and see what we'll get. So I'll say 7. So 7 is 111. So that is what I got as an output, right? So if I okay, let us try to convert another number. So let us take a bigger number now. So I'm going to say 27, right? So let us try to write this 1 2 4 8 16. So you need 116 for this. So we'll take a blue color. So for this you need 116. Okay, 16 plus 8, you'll get 24. 24 plus 2, 26. 26 plus 1, 27. This 4 will be left with 0. So 11011 is the binary format of 27. Let us run this program and insert 27, and we'll see what we'll get. We'll get 11011 in a binary format. So this program is the right program to convert a decimal number to a binary digit. Okay, so we have got the output. So let us go for the next question right now. So this is the second question. We have got the right answer. So let us mark this as done. So we're done with the first question and we're now done with the second question. So let us move ahead for the third question. So write a program to convert a number from decimal to binary. So now let us start with our third question. So this is the third question for this video. So the question says that design a calculator to perform basic calculations. So you will be given an input and the input format is num1 space num2 and an opcode, that is an operand code. So the value of opcode will be plus, minus, multiplication and division symbol. So you have to perform these four operations on these given numbers. So you have to design a basic calculator. So we can do that, and let us discuss the question more in detail. So I'm going to take my pen and I'm going to set this size. So what this question says is that they will give you a number, says num1 space num2, and these numbers will have some value, and after this number they will give you another variable, that is opcode. So that is the input. So these two numbers are either integers or floating point numbers, and this is a char. Okay, so we know this is either integer or a floating point number, right? So this is a character which will have plus, minus, division. This is division, so division is not like this becomes a mod. So division and multiplication, right? So these four will be there. So what can we do as a solution? So in a program, what we can do is we can have an if condition that checks the opcode. We can take an opcode and we can check. So when the opcode is equal to plus, okay, if it is equal to plus, what we can do is we can perform the addition operation. Else when it is not addition, if it is subtraction, we have to again compare and do the subtraction operation, and so on. We can go and do this. So this will make a program a little more complex. So we can simplify this whole thing. Okay, so instead of doing all this, what we can do is we can use something called as, we know that, and that is called as switch cases. So we all know about switch, right? So what you can do is you can take a switch case of this opcode, right? Switch opcode, and you can say that case plus, whenever the case is plus, you can perform the addition operation. Whenever the case is minus, you can perform the negative operation. So whenever the case is multiplication or division, you can perform that, and then you can print that answer. So you can also have a default case which will say no. So why do we need a default case that says no? So whenever the operand is not these four, if people enter anything else than these four as an input for the opcode, so we cannot perform that operation, right? It may be not at all a mathematical operation. It can be anything. So it may be anything, right? So from the keyboard. So at that time, what we have to say is we have to say no. So that no represents that it is a wrong set of input that is given by the user. So this is how you can handle your error or undecided input that is given by users. So that is how you have to design this program. So it is very simple. Just take num1 as an input, num2 as an input, and the operation code, and then have your switch case and calculate the result and print it on your computer screen. That is the end of this program, right? So let us go to our IDE, and then we can start writing the code for this. Okay, so my IDE is this. So I cleared them all, so I'll again have to include stdio.h, and I will start with my int main, and my int main will return 0, and from here I'm going to start fresh. So what I have to do is I will declare two floating point numbers, that is num1 and num2, and I'll declare result variable. Okay, I don't need to declare a result variable even. Okay, so we'll manage without the result variable. And then what you can do is we have to declare another char that says opcode. Now what we have to do is we have to say scanf. We have to take %d, %d, %d. We have to take three numbers, that is ampersand num1, ampersand num2, ampersand opcode. So there is an error in this line. If you have noticed, this opcode is a character and we have to take %c, right? So now we're done with taking inputs. So let me write a comment, taking input, right? So next what you have to do is calculate, right? So what I'm going to do is I'm going to take a switch case, and that switch case will have the opcode, and I'm going to say if the case is such that it is a plus operation, then what I'm going to do is I'm going to say printf %f, and I'm going to print num1 plus num2. Okay, so this will print the addition result, and I'm going to apply a break operation. So I could have also taken a result variable here, and I could have stored this num1 and num2 in result and then print the result here. That will be a inefficient code, and that will also take more memory. So that is why I have done like this. So next I'll say if the case is such that it is minus, then I can say printf %f, I can say num1 minus num2, right? So next, if my case is multiplication, that is also very easy, right? So here I'll give and here I have to give a break operation, otherwise it will keep on executing the next conditions also. So next I will say printf %f num1 into num2. So now I'm going to apply a break operation. I'll remove this space so that it looks good. And the last but not the least, division operation. So if my as a %f, if my input operation is that I want a division operation, I'm going to say num1 by num2. Okay, and you have to apply a break. So one thing you can do, but before doing that, is that you can handle an exception. We can say that if num2 is equal to 0, you cannot divide anything by 0, right? So what you can say is that you can printf no, and then you can break the case, right? So that is what we can do. Otherwise we're going to print the division operation result and then break the case. So we will have another default case that will say printf no. So as I said before, so this will handle all the cases where the operations are not these. So this num2 is because, so if you try to divide any number by 0, you will get an undefined action. So that is not defined in mathematics. So what you have to do is we have to prevent this case. So if at all the num2 is 0 and you are trying to divide, you will say no and then you are exiting. So this is the code, a very simple program to design a small simple calculator using a switch condition. Let us try to execute this. So it executed without any problems. So now I'm going to say 3 space 7 and I want a plus operation. So I'm getting 0 for this because of the error that was given here. So format %d accepts of types of int star but has 2 argument of float. This is line number 9. So this is because this is %f and this is %f. So because these num1 and num2 are floating point numbers, so you did not notice this in the initial part of the program when we write. So 3 space 7 space plus will give you 10, that is 7 plus 3, right? So now what we can try out, right? 3 7, and if I say minus 3 minus 7 is minus 4. So if I give say 5 by 0, if I say division, this will say no because we cannot divide 5 by 0, so that is an error. So this program will also handle the conditions like if I say 23 and 45, and if I say I want this operation doesn't even exist, so this will say no because we have not defined it, and this will execute this default condition here, right? So this default condition is executed and we are getting no as an output. So this is a small code. So yeah, So that is the end of the third question. So as we were doing before, we will say that this program is done by marking a tick, and we will go for the last question of this video. So the last question of this video will be a little bit tougher than this, so you should know a little bit of algorithm to do it. So let us read out the question. The question says that write a program to perform binary search on a one-dimensional array of n elements. So what we have to do is we have to perform binary search on a one-dimensional array of n elements. So what does this mean? So let us go to Paint, clear this. So it says I have to perform a binary search on 1D array, right? So what does this mean actually? So let me grab a pen and write. So what does this mean? So we know this term 1D array. So if you're familiar with data structures and algorithm, you'll be knowing this binary search algorithm. If not, I am going to explain you this in this video, so don't worry. So what it says is we have a 1D array that has certain number of element, and what we have to do is you have to do binary search. We have to search some number. This means that there are some elements and you will be given an element and you have to search this element in this array, and you have to say whether if this element is present, give the index number. So the index number starts from 0, 1, 2, 3. So if it is present, then give the index number. If it is not, then just say no if it is not present, right? So that is what the program is saying. So you have to perform a binary search on this. So there is something called as linear search. What we can do is we can take this number and compare it with this. So if it is not equal, again take this number and compare it with this, and you can go so on up to end of the numbers. But this is not an efficient algorithm. So what the binary search says is that, let us say, for binary search to work, you need to have a sorted array. So let us take a sorted array of elements. So let us say 3, 5, 7, 8, okay, 9, 9, 1, 1, 53, 999, okay. So that is it. So we'll take only these elements for now. My bad. Okay. So what we can do now in binary search is that we will take three variables, that is start, end, and mid. So this binary search to work, we need a sorted array. So you have to enter a sorted array. Okay. So next what we're going to do is we're going to go to the middle of this list, right, and check. So let us say if I want to find 54. So what I'm going to do is I'm going to go into the middle of this list, and then I'm going to check the middle of I'm going to compare 54 with the middle of the list. So middle of the list, let us say in this case, is if it is 9, so 54 is greater than 9. So since 54 is greater than 9, I know that 54 does not come left of 9 because it is a sorted array, and 54 must be definitely right side to 9 because it is greater than 9. So I can neglect all these, right? And then I'm left with 11, 54, and 99. Now what is the middle of this list? 54. So I'm going to the middle of this list and I'm going to compare 54 with 54. Yes, it is matching. And then I'm going to note the position of it. What is the position? 0, 1, 2, 3, 4, 5, 6 is the position of this, and you're going to print 6 as a position. Okay, so another example if we want to take is that, say, let us say I have if you take an example of a dictionary. Okay, so it is a dictionary. So this is a page in a dictionary. Okay, so you have some names here. Okay, so all the names in the dictionary will be sorted, all the words in the dictionary, right? So what you want to do is that you want to find the name of the meaning, meaning of the word. Let us say son. So son means child of a person, right? So what you want to do is, you took up the middle of this dictionary. Okay, so this is a dictionary, so you open up the middle of this dictionary. So what did you find in the middle of this dictionary? Let us say you found a word with M. Okay, so since you found a word with M and this dictionary is alphabetically sorted, you know that the word son is not left to the M word. So what you can do is you can neglect the left part of the dictionary and you can only start looking to the right part of the dictionary, right? So every time you're searching, you're going to the middle and you're neglecting a half part of it and only considering that next half part. Next, here what you're going to do is you are again dividing it in half, and you're considering only one of these half parts, right? So that is what is called as a binary search. And binary search is an algorithm that you are going to study in data structures and algorithms class if you have taken. So let us apply this and write a program to do this. Okay, so I'm gonna clear. Sorry, my code blocks just closed by mistake, so I'm going to open it again. So I hope you understood what is binary search till then, right? So it is just basically going to the middle and then searching for it. Okay, so that is it. So every time you go to the middle, you're comparing the element to be searched with the middle element, and you're verifying if it is the right one or not. So I'll create a new project. So if you have not seen how to create a new project here, go to console application. So there is an option called console application. I'm going to create a C++ application. So I'm going to name it mock, and I'm going to say next, and I'm going to say finish. This will create a mock, and inside this sources there'll be a main.c file. If I open this, there will be a default hello world program written for me. Okay, so I'm going to increase the size. I'm going to delete this and let us get started. So initially, what do I need? I need a sorted array. Remember, I need a sorted array and a search element. Okay, so what I'm going to do is I'm going to say int n, that is the length of the array. Okay, so what I'm going to do is I'm going to say scanf %d %n. So I am taking the length of the array as input from the user. So then I'm going to say int arr of n. So now I'm declaring an array of size n. Okay, so this array has to be in a sorted order. So I'm going to take this array as input from the keyboard. So for int I is equal to 0, I is lesser than n, I plus plus, I will say scanf %d ampersand arr of I, right? So I took the array as input from the user, right? So next what I'm going to do is I'm going to have to take the search element. So I will declare int ele. So ele is the search element, or I will declare it as search ele. Okay, so search ele is a search element, and you will say scanf %d search ele. So you have taken the search element. Now you have to search. So to search we need 3 variables, right? So the first variable is start, end, okay, and mid. And what I'm going to do is I'm going to initialize the start with 0 because we are starting from the array left position, right? So here what we're going to do, so previously when I explained you searching an element, so I'm doing a lot of control C's here, so it is not here. So whenever you have an array of numbers, you're going to the middle of it, right? So how do you know that is the middle of the array? So you need to know the start of the array, you need to know the middle end of the array. What you can do is start plus end by 2. Whenever you do that, you're going to get the middle of the array, right? So that is why you need a start and end. So let us say whenever you compare your number with the middle element and you found out that that number lies on the right side, what you can do is you can take this start and you can bring that start here. So what this will do is it will neglect all these elements. So you are only searching from start to end. Okay. Again, you have to calculate mid. That mid will be start plus end by 2. So the new start is here. So this start plus this end by 2, the mid will come here again. Okay. So that is the procedure. So this you will do again and again until you find the element. So for that, I need my start to be equal to 0 and my end should be equal to n minus 1. That is the last one, right? So now what I'm going to say is I'm going to say that while start is lesser than or equal to end. So while this start, see now we have come closer to the searching this element. So that is why the distance between start and end is decreasing. So it will decrease until this start and end comes to a same number, only one number, right? So the start should be lesser than or equal to end, and the starts will be actually lesser than end, not also equal. So next what I'm going to do is I'm going to say mid is equal to start plus end by 2. So that is what we did earlier, right? So next what I'm going to do is I'm going to compare if my search element is equal to ARR of mid, that is if the middle element is compared, what I'm going to do is I'm going to take a position variable and I'm going to say position is initially -1. Okay, so if my element is searched, I'm going to say, note down the position. So position is equal to mid and I'm going to break the array, now break the loop. So if it does not and if it does not and if our search element is greater than the array of mid. So what this means is that whenever I compared here, previously I compared here, right? So you're comparing your number with this number. So let us say there is 9 here and we took 54. We are comparing 54 with 9. So 54 is not equal to 9. So this condition won't execute. So next what happens is 54 is greater than 9, right? So if 54 is greater than 9, what you have to do is move this start to here, right? If let us say you want to search, let us say there are this many numbers and you are comparing to the middle and you want to search 3 and the number is 9. So when the number is, the search element is lesser than the middle element, what you have to do is that you have to start from here and you have to move your end here to here. Now you're neglecting this part and you're searching only this part. So that is what we are doing here. So if the search element is greater than mid, what you have to do is you have to say start is equal to mid plus 1. Otherwise the element is lesser. So then what you have to do is end is equal to mid minus 1. Okay, so that is done. So what you do after this looping, so this will loop and it will check if the number is not there or not. If your position is greater than or equal to 0, what you want to say is you have to print the position. Okay, otherwise you have to print no. So why this otherwise is because initially the value will be -1. So even if the first element, the 0th element is your search element, so your search element lies in the first number itself, this position will be equal to 0 and then you have to print 0. But if you did not find that search element, the value of position will be -1 itself. So then this condition will get filled and no is going to be printed. So I hope you have understood the program. So this is the simple program to apply binary search on an array of one dimension. So you have to take an array input and then declare an array with size n. Then you have to take that array as input using scanf, and then you have to intake the search element that you want to search, and then declare start is equal to 0, end is equal to n minus 1, and a mid and a position variable initialized with -1. And then you have to loop and you have to calculate mid is equal to start plus n by 2. And if your search element is equal to mid, note that position and break the loop. So you end the loop. Else, if your search element is greater than the mid position, since this is a sorted array, your search element is greater than the mid position, that means it is to the right side of the mid position. So you have to move your start to the right side of the mid, that is +1. Else what does it mean? It means that it is not, the search element is not equal to the mid, it is not greater than the mid, then definitely it must be lesser than mid. So that is why you have to move your end to the left of a mid, that is mid -1. So next, if your position is greater than or equal to 0, that means you have noted down your position here and you are printing that position. Otherwise, what you're doing is you are saying no, which means that the search element is not found. So this is the binary search program. Let us try to run this program. Okay, so there is an error here. So printf, sorry, yeah, there must be another error. We'll correct that error. So yeah, so let us take a number of array of size 5, and the array should be actually in increasing order. So I'll say 1, 3, 5, 7 and 9, and now I have to enter my search element. Let us say I want to search 7. This is not executing, so there must be an error. So let us try to debug. This is fun, right? Okay, so it is the error, it says is in the line 16. So I have not taken ampersand ELE, search ELE. So what this ampersand will do is it will store the number in the memory block. Okay, it will, if I don't enter this ampersand, it will not save the memory, and that is why we didn't get the output. So that was the mistake that we had. So we have ampersand here. Now the program seems correct, there is no error, and this program is going to execute now. So 1, 3, 5, 7 and 9 I have entered. I want to search 7. The position of the number 7 is 3, so this is 0, 1, 2 and 3. We have searched it. So we can even do this for we'll take long numbers, we'll take 10 numbers. So I'm going to say 1, 3, 5, 7, 9, 11, 13. So how many numbers are over? 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5, 6, 7 numbers are over. 7, 8, 9 and 10 numbers. So now what I want to do is I want to search for 19. So 19 is in the 9th position. So 19, oh sorry, it says 19 is not present. Okay, so I think we have to say search is lesser than or equal to end. Let us try to do now. So now the program should execute. So whenever you're writing a program, you should execute it multiple times and see whether the program works or not. Okay, so that is a better thing. Okay, so even I am not perfect, so that is why. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I want to search 19. The 19 is in the 9th position. So the start and mid will point to this number itself at the end. So you are searching 9 initially because mid is this. So your search element is 19, it is right side. So your search space is only this. So the middle of this element is this. You are comparing it to this. Since 19 is greater than 15, your search element is only these two. So the middle of these two is this. So since this is not, it will, at the end of this program, it will come to 19. At this point, the start and end is pointing to the same number itself, and that is why you have to add this equal to number, okay, or equal to sign here. So this is the program to find or to search an element in a one-dimensional array using binary search. So for this binary search, you need a sorted array. So we have completed this program. So that is it for this video. So we had 4 programming questions. We have solved it. So thank you for watching this video. So if you have any doubt in this video, please do ask the question in the comment section. We will be happy to answer. I'll be answering them personally. So if your friends are preparing for any kind of examinations, maybe TCS or some other examination, uh, do share this video and subscribe to our online YouTube channel, Online Study for You, and press the bell icon to know whenever we upload any video. We upload videos on verbal aptitude, programming stuff, and etc. to help you prepare for any interviews or examinations that are coming. So once again, thank you for watching this video. Happy learning.